cinnabar and cinnabarite, likely deriving from the Greek kappa iota nu alpha beta alpha rho iota, refer to the common bright scarlet to brick red form of mercury sulfide. Formula: mercury 2 sulfide. That is the most common source for refining elemental mercury, and is the historic source for the brilliant red or scarlet pigment termed vermilion and associated red mercury pigments. Cinnabar generally occurs as a vein-filling mineral associated with recent volcanic activity and alkaline hot springs. The mineral resembles quartz in symmetry and in its exhibiting birefringence. Cinnabar has a mean refractive index of 3.2, a hardness between 2 and 2.5, and a specific gravity of 8.1. The color and properties derive from a structure that is a rhombohedral crystalline lattice belonging to the hexagonal crystal system, crystals that sometimes exhibit twinning. Cinnabar has been used for its color since antiquity in the Near East, including as a rouge-type cosmetic in the New World since the Olmec culture, and in China since as early as the Song dynasty, where it was used in coloring lacquerware. Associated modern precautions for use and handling of cinnabar arise from the toxicity of the mercury component, which was recognized as early as ancient Rome. Etymology: the name comes from kappa iota nu alpha beta alpha rho iota, a Greek word most likely applied by Theophrastus to several distinct substances. Other sources say the word comes from the Persian shangaf, a word of uncertain origin. In Latin it was sometimes known as minium, meaning also red cinnamon, though both of these terms now refer specifically to lead tetroxide. Properties and structure. Properties: cinnabar is generally found in a massive, granular or earthy form and is bright scarlet to brick red in color, though it occasionally occurs in crystals with a non-metallic adamantine luster. It resembles quartz in its symmetry, it exhibits birefringence, and it has the highest refractive index of any mineral. Its mean refractive index is 3.08 versus the indices for diamond and the non-mineral gallium arsenide, which are 2.42 and 3.93, respectively. The hardness of cinnabar is 2.0 to 2.5 on the Mohs scale, and its specific gravity 8.1. Structure: structurally, cinnabar belongs to the trigonal crystal system. It occurs as thick tabular slender prismatic crystals or as granular to massive incrustations. Crystal twinning occurs as simple contact twins. Note: mercury sulfide, mercury 2 sulfide, adopts the cinnabar structure described, and one additional structure, i.e. it is diamorphous. Cinnabar is the more stable form, and is a structure akin to that of mercury 2 oxide. Each Hg center has 2 short HgS bonds, and 4 longer HgS contacts. In addition, mercury 2 sulfide is found in a black non-cinnabar polymorph that has the zinc blende structure. Occurrence: cinnabar generally occurs as a vein-filling mineral associated with recent volcanic activity and alkaline hot springs. Cinnabar is deposited by epithermal ascending aqueous solutions far removed from their igneous source. It is associated with native mercury, stibnite, realgar, pyrite, marcasite, opal, quartz, chalcedony, dolomite, calcite and barite. Cinnabar is essentially found in all mineral extraction localities that yield mercury, notably Puerto Princesa, Almadén, New Almaden, Hastings Mine and St. John's Mine, Vallejo, California, Idria, New Idria, Giza, Egypt, Moshulonsberg, Niroba Moshul in the Palatinate, Ripa, at the foot of the Apuan Alps and in the Mount Amiata, the Mount Inuvala, Huac Velica, Murfreesboro, Arkansas, Talingua, Texas, and the province of Guizhou in China, where fine crystals have been obtained. It was also mined near Red Devil, Alaska on the Middle Kuskokwim River. Red Devil was named after the Red Devil Cinnabar mine, a primary source of mercury. It has been found in Dominica, Lesser Antilles near its sulfur springs at the southern end of the island along the west coast. Cinnabar is still being deposited, e.g., at the present day from the hot waters of Sulphur Bank Mine in California and Steamboat Springs, Nevada. Mining and extraction of mercury. As the most common source of mercury in nature, cinnabar has been mined for thousands of years, even as far back as the Neolithic Age. During the Roman Empire it was mined both as a pigment and for its mercury content. To produce liquid mercury, crushed cinnabar ore is roasted in rotary furnaces. Pure mercury separates from sulfur in this process and easily evaporates. The condensing column is used to collect the liquid metal, which is most often shipped in iron flasks. Toxicity. Associated modern precautions for use and handling of cinnabar arise from the toxicity of the mercury component, which was recognized as early as in ancient Rome. Because of its mercury content, cinnabar can be toxic to human beings. Though people in ancient South America often used cinnabar for art, or processed it into refined mercury, the toxic properties of mercury were well known. It was dangerous to those who mined and processed cinnabar. It caused shaking, loss of sense, and death. Data suggest that mercury was retorted from cinnabar and the workers were exposed to the toxic mercury fumes. Overexposure to mercury, mercurialism, was seen as an occupational disease to the ancient Romans. Mining in the Spanish cinnabar mines of Almadén, 225 kilometers southwest of Madrid, was regarded as being akin to a death sentence due to the shortened life expectancy of the miners, who were slaves or convicts. Decorative use. Cinnabar has been used for its color since antiquity in the Near East, including as a rouge-type cosmetic, in the New World since the Olmec culture, and in China since as early as the Song dynasty, where it was used in coloring lacquerware. Cinnabar's use as a color in the New World since the Olmec culture is exemplified by its use in royal burial chambers during the peak of Maya civilization, most dramatically in the tomb of the Red Queen in Palenque, where the remains of a noble woman and objects belonging to her in her sarcophagus were completely covered with bright red powder made from cinnabar. The most popularly known use of cinnabar is in Chinese carved lacquerware, a technique that apparently originated in the Song dynasty. The danger of mercury poisoning may be reduced in ancient lacquerware by entraining the powdered pigment in lacquer, but could still pose an environmental hazard if the pieces were accidentally destroyed. In the modern jewelry industry, the toxic pigment is replaced by a resin-based polymer that approximates the appearance of pigmented lacquer. Other forms. Hepatic cinnabar aragite is an impure brownish variety from the mines of Idria in the Carniola region of Slovenia, in which the cinnabar is mixed with bituminous and earthy matter. Hypercinnabar crystallizes at high temperature in the hexagonal crystal system. Metacinnabar is a black-colored form of mercury sulfide, which crystallizes in the cubic crystal system. Synthetic cinnabar is produced by treatment of Hg salts with hydrogen sulfide to precipitate black, synthetic metacinnabar, which is then heated in water. This conversion is promoted by the presence of sodium sulfide.